Hey guys, Stat 1800. This is the first video. I'm only going to put up one video this week because I mean you got a lot going on with getting my stat lab. Watching the introductory video, understanding what I'm going to put you through the next for the rest of the semester. So I'm going to keep it pretty simple in this in this first week. I'm not a fan of PowerPoint, but I think there are times that PowerPoint is appropriate, and that's what I've determined here. Really, I'm just going to throw a lot of definitions and some vocabulary at you. This is a place where it's extremely important, I think, to get your notebook. Go ahead and get it organized, and get snapshots of this. In your notebook. The one thing that I'm even less fond of than PowerPoint is someone giving me a PowerPoint presentation and then reading it to me. And if I catch myself doing that, I'm going to slap myself because I don't like that. So I'm not going to do that. So I'm going to hit the high points, and I'm sure I'll have some random stories I'll throw in about things. It might be a good time to step back and tell you a little bit about me. I've been at Shawnee now since 1994, so you do the math, and I teach everything from the undergraduate statistics, undergraduate mathematics, statistics, calculus, you name it, all the way up to the graduate program. Currently, I'm the director of the graduate program in mathematics, so it gives me a wide range of experiences. But the thing I really feel I like most about my job is helping students with their research. I think now I'm currently working with 4 PhD students from Nova Southeast University. I'm the advisor to 9 PhD students in my past, so I've successfully helped 9 students get their doctorate. I think I'm up to 21 master's thesis advisors for 21 of those. So, I love that. That's because I love teaching too. But I think helping students one-on-one pursue their dreams and complete their research is something I really, really like. But I think the reason I like the 1170, the finite mathematics, and the business statistics so much is I do have a little bit of a business background. So, combining the research aspect with the business experience before, actually I started a business when I was going through undergrad and grad school. So that's what helped put me through my education. So, yeah, I got a little bit of experience there. But let's get to it. I'm never really comfortable talking about myself, but I just spewed that right out, didn't I? All right, guys, objectives. What am I going to teach you in this class? Well, I'm going to teach you a lot of stuff. We're going to start kind of from square one to square whatever it may be, Z, I guess, and talk about different things in setting up a study, defining the goals of the study, all the way up to collecting your data, and then ultimately what we lead into the analyzing the data phase. So lots of stuff going on here. First thing we do is once we establish the goals of the study and we define the operational outcomes and all that fancy stuff, we'll start collecting information on our subjects. And subjects can be people, they could be grocery stores, they could be a manufacturing process, they could be ball bearings. So we collect measurements, collect information. Well, one of the first things we do is we identify those variables by type. Now, variables is an important name because variables to me implies that the responses vary. So if I know someone who's teaching at like an all-girls school and I want to do a study, then the variable gender is completely irrelevant. It's of no help whatsoever because I have no variation in gender because I'm collecting measurement and information on students in an all-girls school. So anyway, once we get our variables, again, expecting variation, we can classify those as categorical or numerical. Luckily, this is one of the easier things we do. I'll tell you what, I want to make sure that I am recording. Let me get out of this, and I just had a Yeah, I'm recording. All right, cool. That's good to know. All right, so categorical, we also call that qualitative, and that's just where your variables, your responses are put into a slot, put into a category or a subcategory, and I'll give you some examples of those on the next page. Numerical, we call that quantitative. There are two types of numerical variables. We have discrete and continuous. I think of discrete as something that is countable and continuous as something that's measurable. I think this will become clear when we look at examples. Speaking of, I have three questions here we could ask potentially students at Shawnee State University. Do you have a Facebook? Do you have a Snapchat? Do you have an Instagram? My 13-year-old daughters tell me that Facebook is no longer cool, that only old people have Facebook. Okay, all right, but anyway, the response would be yes or no, so clearly the variable type would be categorical. How many text messages do you send in a 3-day period? Well, that would be something that is countable, so it's numerical, and because it's countable, it would be discrete. How long does a mobile app take to download? So that's, again, how long would be something you would measure in terms of a quantity, so it would be a numerical, and because it's measured, again, it would be continuous. Types of variables, nice little flow chart here. We start out with variables. Again, those things vary, and they divide into either categorical or numerical, and numerical breaks down into two types, discrete or continuous. Now, let me get on a little tangent here. Up in the right-hand corner, you are going to see DCOVA. One of the things I'm putting up this video at home, and one of the things about putting up videos at home is dogs bark, UPS men, women. Actually, all of our UPS people are men, so they show up, so there's distractions, and I just had a distraction, so sorry about that. Anyway, DCOVA, what's that all about up in the right-hand screen? That's just a way of kind of defining a process by which we can analyze data. We can evaluate a research goal, if you will. So the D stands for define. You define what you want to do, what you want to know. The second C stands for collect. You go out and you collect your data. And hopefully you collect your data in a reasonable way. O stands for organize. Now, once you've collected your data, you want to organize your data. V stands for visualize. That means create one of these really fancy types of graphs that I'm going to teach you. Histograms, box plots, pie charts, bar charts, combinations of those things. And finally, the A stands for analyze. So once we get our data collected and we look at pictures and kind of summarize the data and organize it with pictures, we want to analyze the data and see what it tells us about the goal of the study. Sometimes categorical data meets quantitative, and we often code categorical with numbers. You often see when you collect gender, information on gender, coding as zeros and ones. And sometimes in your data set, you'll just see them as zeros and ones. There won't even be a reference. Well, there'll be a reference, but it'll be someplace else. What zeros and ones stand for. So always be on the lookout in a data set when categorical variables are coded with numbers, because they have to be treated appropriately. We do a lot of survey. Business statistics folks seem to love surveys, and it makes sense. We often report responses from those surveys as numbers, strongly agree 1, disagree 2, and so on and so forth. So just keep that on the back burner, keep that as an option, because what's going to happen eventually, just like we started with that flow chart where we have variables and then we look at whether it's categorical or numerical, and then numerical whether discrete or continuous. As we move forward in our class, we're going to have different statistical techniques that are going to be appropriate depending on the type of data that we have. For example, if we have categorical variables, then we're going to learn something called chi-square. If we have quantitative, then we might do a t-test or a two-sample t-test, or maybe even look at some regression, simple linear regression or multiple regression. But then sometimes we get where categorical and quantitative variables meet, and that's a situation where we might get into ANOVA or a two-sample t-test. So fun stuff, guys. It's coming. It's going to be coming. It's going to be a fun class. So. Collecting data correctly is a critical task. First thing, if you collect your data incorrectly, it leads to something called a bias. And bias is just a deviation from the truth. I never will forget when I was teaching this class at the University of Kentucky. It was right after the University of Kentucky won the NCAA championship. Now, this is not the 2012. If you're a avid Kentucky fan like me, I'm talking back in 1998. I was teaching part-time there, and they had a student who was interested in the percentage of UK students who watched the final game. So in other words, who was interested in Kentucky basketball. And she came back to me and she said, well, I went out and sampled 100 people, and I found out all 100 people watched the game. Does that mean that every person at the University of Kentucky watched the game? Well, that's kind of goofy. It's a goofy conclusion. Well, I found out that she collected her data at a sports bar on Friday night. Well, she had bias in her results because clearly not everyone at the University of Kentucky watched the final game, because I've been in the library a lot, and I know there's some people hanging out in the library that don't even know Kentucky has a basketball team. But if you're hanging out in a sports bar, chances are you're going to get a deviation from the truth. So flawed data is not good. Again, it results in error. It results in biases. So it doesn't matter what kind of statistical model you lay out. You can lay out the most elaborate two-way ANOVA and look at all these marginal means plots and do all this fancy stuff. But if your data going in is flawed, then our output is going to be flawed. Developing operational definitions is crucial. Operational definition just says let's have a clear, concise roadmap for defining what we want to know. So, in the DCOVA acronym, define what you want to know, and lay out a clear roadmap for doing that. Now, sometimes in that phase, even after you finish this class, you're not going to be a statistical expert, but you might go into a job and they're like, well, you had business statistics, so help us evaluate this business phenomena, whatever it may be. Maybe we're looking at a manufacturing process. Maybe we're looking at an advertising campaign, whatever it may be. Sometimes, and oftentimes, you need to bring in an expert and help you define your study. I do a lot of studies with SOMC, and finally, typically what they do is they define the goals of their study, and they carry all this out, and then they bring me in at the A stage, looking at the DCOVA, where it's time to analyze the data. And I tell them, guys, this is not good. We can't analyze this data because of the way the study was developed and carried out in the initial stages. So I finally told them, I said, don't bring me in on anything unless I'm brought in on the D phase, where you're actually defining how the data is going to be collected and address the goals of the study. So, operational definition, what you want to know, and a clearly defined roadmap for what the way you're going to set your study up, the way you're going to conduct it, the variables that are going to be collected, the measurements that are going to be analyzed. Extremely important. It's kind of like building a house on sand if you don't. You might put the most elaborate $1.5 million house, but if you've out there built it on sand, pretty soon the ground's going to shift, and you're going to end up with, wouldn't you know it? I don't know about you guys, but I am getting more and more calls from people that I don't want to get calls from. It seems like more and more spam coming through. So I don't know. And I'll tell you something else they're doing. They're getting clever. Like my area code is 859, and then the first three digits are 473, which to me, when I see that number, indicates I'm getting a call from the local area. Well, they're getting pretty clever, and they use that number to kind of trick you, where you know. So anyway, I'm not real pleased with all this. Establishing a business objective. Take a second to read those. Again, I'm not going to read this to you. You guys are big boys and big girls. You can read. I do the second one there. Kind of interest me. A pharmaceutical manufacturer needs to determine whether a new drug is more effective than those currently in use. Well, let's think that one through. The first thing you would, apparently there's been some research where the current drug can be improved. And, how would you carry something out? Well, that would be a pretty sophisticated design because, first of all, I'd want a target audience. And let's just say that this drug is to lower cholesterol. So my population under interest, or population of interest, would be people with high cholesterol. But to me, there's a difference between somebody who has a cholesterol level of 200 and 400. So we might want to come in and be more targeted in the groups that we're analyzing this. And that to me would be kind of a classic control experimental design. The control would be the patients who are currently using the current drug, the one that's currently in use, and then you might want to select an experimental group who uses the new drug, and then you would compare to see if there's any difference in either reducing or stabilizing cholesterol. So, lots of different things that we can look at in the business setting in terms of establishing a business objective. Sources of data. We have primary sources and secondary sources. I usually, when I'm consulted by hospitals and I'm working with a lady in Florida right now who's analyzing some survey data, and SOMC and this nurse in Florida, they are the primary sources because they're the ones that have kind of designed. They've collected the data, and I'm kind of the secondary source. I'm brought in to perform the data analysis. Guys, I don't like this distinction between primary and secondary. I'm a firm believer that the person analyzing the data needs to be included and consulted as a primary source as well. So just my 2 cents worth. Sources of data fall into 5 categories. Data distributed. Now, I am going to read to you here because I want to make some distinctions. Data distributed by an organization or individual. I'm giving you some examples there. An example at the school level, there's data that we have collected on Shawnee State University students that's just sitting there. And, stat geeks like me sometimes want to try to find these underlying characteristics of students who are successful. So I might want to go out and just look at data that's already been collected to evaluate that. Second thing is a designed experiment. That's an experiment means typically you have a setting and then you come in, you do something to that setting, and then you evaluate what happened to that setting after the experiment. Experiment, I like to think that there's some sort of external force injected into the situation. Survey, surveys, we just lose our mind with surveys, especially around politics, especially around presidential elections. I found it really, really interesting. I received an email the day before the election from a friend of mine. I actually graduated with her, and she is a diehard Republican, and she knows I'm a statistician. She knows that I follow the political data very, very closely, and I make my own predictions. And actually, I do pretty well. And she wrote me an email the day before, and she said, "So Doug, who's going to win?" And I said, Trump's going to win. And she said, there's no way. She said, all the surveys, all the polling agencies predict that Clinton's going to win. So I said, well, I'm not going to go into the reasons here, but I told her that, and actually it turned out to be true. So I either got lucky, or I knew what I was doing, or maybe a little bit of both. The fourth bullet, an observational study. Again, I always wonder how long. I love Starbucks coffee, and I wonder how long it takes on average waiting in line at Starbucks to get an order. Well, that'd be an observational study. I'd go over and set up a tent, and I would just count cars, and I'd tab each car, and I'd see when they placed their order, and I'd see how long it took for them to get their coffee. The final, ongoing business activities. And I'll give you a pretty good example there. Marketing companies use tracking data to evaluate the effectiveness of a website. So, guys, lots of different ways that we can, in a business setting, be interested in defining studies. So, now, super duper duper important here. Population versus sample. Guys, a population is the large group that we want to make a statement about. Now, back before the presidential election, we wanted to make a statement about U.S. voters. And really we didn't. We wanted to make a statement about those who were going to vote. We really didn't care how you felt unless you were going to vote, because we were trying to predict the outcome of the election. Well, a sample is a subset of your population. It's a smaller group. It's much more manageable. Oftentimes your population is either large numbers, or sometimes it's even infinite. So we go in and we take a sample because it's manageable, and I'm going to teach you all these fancy smancy statistical techniques that allow you to take information from a sample and make a generalization or a statement about the larger group, the population. We do that all the time in presidential elections, right? I don't know how many people voted in the election, but I know it was in the tens of millions, maybe even hundreds of millions. Actually, it's something I should look up. Actually, I have, but I forgot. But in these exit polls and even the election, the surveys before the election, sometimes we make statements on tens of millions of people based on 1,000 people. A lot of people say, well, you can't do this. The sample size isn't big enough. Actually, it is. Actually, it's a very adequate sample size to make a statement about a larger population. But keep in mind, we get into things called error, sampling error, margin of error, all those things I'm going to teach you in this class. So population versus sample. The left, you see you got a bunch of people. You want to draw a conclusion about them, and on the right you come in and you collect data on just a portion of the population. Collecting, why should you use a sample? Time, cost, practical. Ran into a situation one time where we wanted to look at IQ scores for a subset of students at the University of Kentucky. Well, IQ tests take a long time. I mean, I know we get on Facebook and we take these goofy IQ tests, and we think that, and they usually overestimate your IQ, but we think that our IQ is like 130 because some goofy test from Facebook told us that. But a true IQ test, and my wife is a school psychologist, and she gives these things, so I know they take 3 to 4 hours. They take quite a bit of time, and they're costly. Well, if I had a population of maybe 10, 12,000 people that I wanted to make a statement about as my population, it would take forever to give an IQ test to all those people. It would be extremely costly, and it just would not be practical. So collecting a sample is usually the way we need to collect our data. Problems. once the data is collected, we need to cleanse our data. And, to give you some ideas, data entry issues. I remember one time I was helping someone analyze some data on middle school children, and we had age, which didn't vary much, so it didn't really help us much. But we had an 88-year-old middle school, or I guess it was elementary school. Well, it's supposed to be 8 years old, but when they typed it in, they accidentally hit 2 8s and it was 88. So you got to cleanse your data and go through and look for those things. Another study I did, I was on Dr. Deb Skurlock, who is the director of the graduate program in occupational therapy. I think she's also the chair. I was on her doctoral dissertation committee, and we had this one guy. She was looking at autism in the workplace, and we had this one guy who was a professor at a university in California who just drove our analysis crazy. Almost every one of his measurements was an outlier. It was kind of outside the typical norm of the information we had collected on these subjects, and he drove me crazy when trying to analyze the data. So anyway, I'm going to teach you ways in StatCrunch to address this stuff, how to cleanse your data. Recoding is sometimes necessary. An example of recoding, let me give you an example. Let's say that you're looking at race, and let's just say that you've broken it down into maybe white, black, Hispanic or Latino, and Asian. For some reason you've done that, and you find out that you have ample sample size in white and black, but when you get down to Hispanic and Hispanic or Latino and Asian, let's say you only have one Asian. So then you might combine the two, Hispanic, Latino, and Asian, into maybe an other category, and that's an example of recoding. Or you might just call it Hispanic or Asian. So recoding is something that we run into. Typically, it's because of sample size issues, but not always. Sampling frame. That's just a way to break down your population into kind of subpopulations. I'm not going to talk about that a lot because I think the next couple of present slides here kind of talk about that quite a bit and give a better illustration. So guys, we got two types of samples. We got probability samples and non-probability samples. Non-probability samples inject judgment and convenience. Let's say that I would like to know something about the effectiveness of online classes at Shawnee State University, and I just decide to analyze you guys because you guys are taking a statistics class from me at Shawnee State University that is online. Well, that's kind of cool because it's very convenient because I have control over this class and I will have the data at the end. But that's a non-probability sample. I'm primarily using that because of the convenience. What I would really want to do is inject a probability sample. So I would want to go in and take a simple random sample of students taking online courses at Shawnee State University in all disciplines. And then we get into stratified, systematic, and cluster probability samples that I'll talk about in just a second. Now guys, the most important one here, I think, is under the probability samples, the simple random sample. The simple random sample means every single person in your population has an equal chance of selection into the sample. Guys, you almost, well, not literally, but figuratively, a very good way to illustrate this is you're trying to come up with, there's some information about Shawnee State University students that you want to know. So you put everyone's, now this is a simplified version, this is not the way I would do it, but this is a good way to illustrate it, a good way for you to think about it. You put every single student at Shawnee State University's name on a slip of paper. You fold up those slip of papers all equally the same way. You throw them in a big tub. You put on blinders, put on blindfold, and you go in and you select whatever sample you want. Literally, every person in that tub, if it's mixed up, has an equal chance of being selected into your sample. Now, first thing, let's get into the non-probability sample. These items are included, chosen without regard to the probability of their occurrence. And again, it's just convenient sometimes to do that. But you got to be really, really careful in generalizing from your statistical results. After you've analyzed your data, you have to be very, very careful in the generalizations you make from the results of your study. The last one to me is just goofy. A judgment sample. You get the opinions of pre-selected experts in the subject matter. Okay, I mean, if you want to know something about teaching undergraduate statistics, maybe you should come and talk to me, because I've taught over 100 sections at Shawnee State. But really, can we generalize from that? That's my opinion. And even a wackier example, let's say we want to know something about a political issue. Should we go talk to our Congress people, congressmen and congresswomen? I don't know. You determine that. What is it they say? Don't talk about sex, religion, politics, or education. If you do, you're bound to create an argument. Guys, the one, the sample, the probability sample is the one that I use, and I think hopefully taking this class from me, you're going to see that the probability model, the probability sampling model is by far the preferred way. Again, there's four ways to do that. Simple random sample, I've talked about, systematic, stratified, and cluster, and I am getting ready to talk about those four right now. Simple random sample, again, I said every single person in your sample has an equal chance, every single person in your population has an equal chance of being selected into your sample. Systematic sample. Now this is kind of interesting. You decide on your sample. Let's say we're going to work with students at Shawnee State University, and I decide I want a sample size of 100. So I'm going to choose 100 students. But then I'm going to divide my N individuals. Now, guys, this is important. That capital N stands for all students in our all subjects in the population. So capital N is a population size. The lower N is a sample size. So I'm going to take, let's say we've got 3,000 students at Shawnee State University, and I've decided that I want a sample size of 30. So big N, 3,000, divided by small n, 100, would give me 30. So I'm going to break this down into groups of 30 individuals. And I'm going to select an individual from each of those groups. Would I ever do that? Maybe. Probably I would. I much more prefer the simple random sample. Stratified sample, we break into some sort of subgroup. Sometimes it may be useful to break students down into race. Maybe we have white, African American, and maybe other. So we're going to divide it maybe into 3 strata, as we call those, and we'll go into each group and pull out samples proportionate to the strata sizes. And what that does, it helps if you've got a particular strata that doesn't have a lot of individuals in it. It guarantees you through the sampling process that you're going to get a proportionate number from that particular strata included in your final sample. And the last bullet said this is a common technique in sampling population of voters across racial and SES lines. So stratified sample, would I use that? Yes, I would. Cluster. Cluster is something you kind of divide. It's divided into several clusters in each representative of the sample. of the population. A simple random sample is a cluster. I don't know. You know, the example they give there. I have another example that I could inject here, but election. You know, they analyze exit polls to try to get an indication of how people have voted. I like those much better than the pre-polls, which it's like, how is a person going to vote? You know, it allows us to go into particular election districts, and you know, you can think of a lot of examples too to use this, you know, for the school setting. Compare sampling methods. You know, there you go. Again, I'm not going to read it to you. To me, and you know, you're going to draw from me because I'm the professor and teacher of this class. But you know, to me, the simple random sample is the most effective. But if you have particular strata that don't have a lot of subjects in that particular strata, then the simple random sample can sometimes miss those folks. So you know, for that reason, a stratified sample does have its value. Cluster sampling, yeah, cost effective. Again, I prefer simple random sample and stratified sampling. Surveys. We have gone survey crazy in this country. And the last couple of slides here are just talking a little bit about a survey. You know, and my PhD is actually in what's called measurement. We get into, well, a lot of surveys and reliability and validity, and you know, is the survey reliable? Is it valid? Does it actually align with the purpose of the survey? So we're not going to get into it at that level, but just keeping it simple. What do we want the survey to tell us? How are we going to collect our information? What do we do with non-response? Measurement errors, you know, good questions give good responses, bad questions give bad responses, and sampling error says that if we give a survey to 100 people and then we're going to tabulate our responses, and then the next day we choose another 100 people and give the same survey, sampling error tells us that these samples are going to vary. So it's called sampling variation. Well, there's going to be error in those samples because they do deviate. So we come up with ways in this class to define the deviation in samples, the variation in samples using sampling error. Types of survey errors. Obviously selection bias. If we exclude people, then we have no idea how they feel. The one that gets me is the non-response, and it was very timely that I think while putting up this video that I got a phone call that I didn't take. It's really hard for those folks that are out, you know, calling people trying to get an idea of how they feel, you know, how to get their responses on the survey, because we have these fancy things like call block and caller ID, and you know, people like me, I don't take those calls. And if I do, I usually try to mess with them. So I'm certainly a non-response error folk and a bias folk because it's what I do. I don't know if you guys have ever seen the movie Silence of the Lambs. If you have, you'll be able to relate to this. I've watched the movie, I bet you 20 times. I love it. It's one of my favorite movies. If you haven't watched it, you really should. But in that, he talks about this very energetic FBI student is trying to analyze this extremely brilliant but deviant mind. He's insane, but he's extremely bright. And so she takes in this survey, and she wants him to fill it out. And he said something to the effect, "I can't believe you think you can dissect my mind with this petty little instrument, this petty tool." So you know, he was so bright that he knew every way. He knew the factor structure, and he knew how to go in and rip that thing apart. So, sorry, that was a Darbro tangent. All right, types of survey instruments, coverage error. Again, there could be a strata. There could be a subgroup that is excluded. Non-response. Think of me not accepting that phone call, which was probably, I tell you what they're probably wanting to do in that phone call is sell me some sort of timeshare. And it probably wasn't a survey, probably more of a timeshare. Sampling error, as I said, random differences from sample to sample, and measurement error. Just bad questions. Sometimes surveys include questions that just don't address the goals of the survey, and that's called validity. Do we have a valid instrument? Chapter summary. What have we talked about? Well, we talked about a lot of stuff. Talked about types of variables, categorical, numerical, also known as qualitative and quantitative. Numerical and quantitative break into two subsets, kind of discrete and continuous. Discrete is countable. How many TVs do you own? Well, I don't know. Let me count them. I see 1, 2, 3, 4. I have 4 TVs. Discrete. Quantitative measurement. Well, what would you measure? What's the weight of your car? What's your weight? What's your height? Well, those are things that you would measure. What's your IQ? We would measure your IQ. We wouldn't count your IQ. So IQ would be continuous, quantitative continuous. What about your ACT? Well, it's not a count. We're not counting anything. We're measuring something. I don't really know what we do measure with ACT, so don't even get me started on how I feel about those things. But I mean, I guess we're measuring some sort of achievement, maybe aptitude. I don't know. So guys, we also talked about collecting data, simple random sample and stratified, the two that I want you to think about, and survey errors. All right, drum roll please. Sneaky quiz number 1. I told you that they would be injected. So sneaky quiz number 1 worth 25 points. Send an email to me. And I've had students before that they're just not paying attention to detail, and they do something goofy like misspell my name or put mymail.shiny.edu instead of the format the professors use here, and they don't get credit. Guys, if you don't get this to me by the due date of your first assignment on my stat lab, I'm not going to take it, no matter what the reasons may be. So, guys, number 1, give. That should be and, not and. Give an example of data that may be collected on SSU students. It is quantitative and discrete. Second, same group of people, quantitative and continuous. And wow, I did a horrible job of typing this out. So number 3, give an example of data that may be collected that is categorical. So guys, get that to me, put it in the body. In the subject line, just put sneaky quiz number 1, stat 11 or stat 1800, and you will get the easiest 25 points known to persons. All right, guys, have a great one. Probably will be the last time I'll use PowerPoint the entire semester, but hopefully it hasn't been too painful. So, guys, have a great day.